Hi, I will show you how you can do that using microcontroller STM32. I will be using Nucleo board and show you all process from beginning till the end. So stay with me. Let's talk about STM32 at all. If you Google most popular controllers, you find it at the first places among other MCUs from Atmel, Texas Instruments, NXP. But why it has such a popularity? And first of all, tons of documentation. Any problem you may encounter while working with it has already been solved by other people. This helps to save you a lot of time during your projects. Second, for its characteristics, it's extremely low-cost MCU, mainly because they're extremely popular and it's a rule in manufacturing anything. The more stuff you produce and sell, the cheaper it will be. Third, versatility. You can find STM32 controllers with absolutely any functionality you want. You can find even specific solutions for a motor control, artificial intelligence, audio and many other fields of your interests. And when you pick section you're interested in, you also will find specific chips for specific tasks you got, for different display resolutions and types. You can even order evaluation board to test it by yourself. And I think it's extremely convenient for studying and prototyping purposes. And to start programming STM32, I would recommend you to use one of such evaluation boards. Personally, I have Nucleo 152RE. Why do I use it? Cause I got it for free and saved money. But you can pick any board you want. And if you have your evaluation board and cable, it's time to start programming. We're gonna use official STM CubeIDE that you can download from ST official site. You can find all links for the software in the description. Now go to the website, download it for operation system you are using, it's completely free, but to be able to download it you must register and confirm your email, extract files, run executive file, and wait till everything installed. You don't need to choose or change anything, except installation folder, if you want of course. After it's installed, run it. Don't be afraid of the interface, everything is easier as it looks from the first point of view. Now we need to create a project. Click File, New, STM32 project, and it starts downloading different files. That means you need internet connection for the first time you create a project. Keep in mind that. After that, in the window that pops, in the board selector menu, you need to pick evaluation board you are using. For me, it's Nucleo L152RE. Here you can find its short description and blah blah. Select board and press next. Now write name of your project. I will name it test. Don't change anything else and press finish. After some time, project will be created. Now at the screen you will see microcontroller used in your board, with its pin names and functions that are currently used. Let's now connect our evaluation board to computer. When you connect it via USB cable, folder opens. There is two files. One of them is log. If no errors is written here, that means hardware part of your board is okay. Another file is just a link for a description of your evaluation board. Here is some info about chip and other stuff, but we are mostly interested in these pictures with the description of all contacts of our board. For example, here we can see LED 1 connected to pin 5 of a port A. Same we see in our IDE. This window inside STM IDE is used to configure our microcontroller without even writing code. At the left side you can see categories you can change. There are different things, starting with the general purpose inputs and outputs, ending by transmission interfaces, displays, timers, interrupts. You can configure here a lot of stuff. Such user interface simplifies microcontroller setup and saves time. Here for example in GPIO tab we can see that we already have 2 pins configured. We don't want to change anything so far. Press this gear to save changes and generate code. Now program automatically will generate code according to settings you put in the previous step. It generates main C file, include libraries and other stuff that aren't necessary at this stage. Now let's look at main C file. To understand what is written here at all, you need to know C language a little bit, and also you need to know what is HAL. HAL is an abbreviation for a hardware abstraction layer. For now you can understand it as a number of different libraries with functions inside. Why do you need them? Originally, to program microcontroller you need to write individual bits into specific registers. Cause it's a hard work, in order to simplify this, there is a HAL, which allows you to write code using functions in more of a human understanding manner, avoiding direct register manipulation. This increases readability of code and speed of writing, but reduces performance. To find HAL functions for your microcontroller, you need to Google HAL and name of your controller. For example, this file is for mine. And before reading, be sure to put a cold towel on your head, cause there is 1300 pages. 1300 pages of technical information. And you can search function for GPIO setup, for example, using search Ctrl+F and read its short description. Let's go back to our STM32 IDE. Here is the most important function in our file, ports initialization. We turn on ports and initialize them according to settings we put it using graphical interface. Also, we can copy function from here. This line set LED output to 0, turns it off. And we can copy this line to use it in a while cycle further. But before we start writing anything in the while cycle, I want to show you something important. Here in brackets are comments that user code begins here and ends here. And if you want to use graphical interface to configure your microcontroller, you must write code in here. Or in other case, your code will be erased. Let's write something here inside brackets and something outside. And then go back, initialize, let's say, pin PA6. Save file and go back. And as you can see, line that was outside the brackets disappeared. To not lose your code, write inside brackets. Now we can write our simple program. In if statement, we read value of our button. The syntax means that if we read 1 at pin connected to button, we do the following. We set LED 2 pin and pin 6. Set means high level. And if else condition occurs, if we read 0 at our button pin, we reset LED 2 and pin 6. That's nice. But what is GPIO pin 6 and LD2? To check what is that, you need to click on it and press F3, and you will be redirected to the defined directive. With define we give our pins names that are more convenient to us. Also, you can do the same with the function to look at its syntax. Now, when 3 lines of code are written, we can program our controller. First, we need to build project. Press project, build project. It's compiling everything for some time, and finally we got 0 errors and warnings. That's a good sign. Next, our step is to click on this little arrow near debug button and press debug configuration. In the pop-up window, click on a STM32 Cortex-M C application. Then click New Launch Configuration. We created first debug config. Here you can see files that we compiled and that will be written in your MCU. We are more interested in debug tab. Here you need to tick ST-Link serial number and click scan. Make sure SVD ticked. Press apply and debug. Your evaluation board, of course, must be connected to your computer. And you may encounter next problem, which is extremely widespread. You have 3 options to overcome this problem. First, update ST-Link drivers from the official site. Reboot STM32 CubeIDE and try it again. If it didn't help, check jumpers on your board. They must be in the next positions. They are responsible for programming, powering your main controller and etc. If everything's fine with them and it still doesn't work, you need to change port number in a debugger tab to a different, for example 61234 to a 61235 or a 6123. And with some number it must start working. When debugging starts, LED on your board must start blinking. Now press this button and that's it. Now when we press the button on our evaluation board, our diode stops glowing. And when we unpress it, LED glows again. And let's head to our practice part. You can ask, hey, we only know how to change state of pin and read the state of pin. We cannot do much with that. And you will be wrong. Use your imagination, fellas.
Imagination.
Here we have our board, some circuitry and 2 wires that go here. And when we press the button, actually when you touch this button, taser that I attached to a door handle turns on and probably tase somebody. You have fun and person you got tased have a muscle spasm. And you can modify the circuit as you wish using your imagination. For example, you can change button for a touch sensor from my previous video. And when somebody touches metal handle, touch sensor will trigger taser. And now you can calmly sip your favorite beverages in your room without any disturbances. Or you can change taser for anything else you want, let's say airsoft gun. And with such a simple piece of code, we already created automatic turret. And it's only a couple examples. You can add any type of sensor you want and control anything you want. So now you know how using only a couple lines of code control everything you want. Subscribe to learn even more. Bye!